Hello guys, so through this video, we will deeply understand whether a certain problem displays permutation or combination. Let's go. Of course, we can only do that if we know their main differences. First and foremost, in terms of their formula, permutation formula is n factorial over n minus r factorial. That's it. In terms of combination, we are using almost similar to permutation, but we will just add, in the denominator, we will just add r factorial. Okay? So let me highlight this portion, r factorial, which is only the main difference between their formula. Now, in terms of the idea, let me use the term in permutation, order does matter. In combination, order does not matter. Okay, what do I mean by this? So simply, to easily spot whether a certain problem is about permutation, try to pick a specific example. Let's say I have the order or the result ABC. If the result ABC is counted different from BAC, even if the subjects are the same, then it's under permutation. Because the order does matter. Having A as the first is different from having A in the second position. Something like that. Whereas in combination, if you will give me the order ABC and the order BAC, this will be counted as 1. Or we may have CAB. So the idea in combination is giving me these three subjects will be the same regardless of their position. Alright? Now you will understand this further through a specific example. So let's do that. For our first problem, I want you to pause this video for a while and then carefully decide whether it's a permutation or combination problem. Okay, so let's say you are setting the combination in a 3-digit lock. You want to use the numbers 1, 2, 3, but don't care what order they are in. Find the number of possibilities. Now, I suggest do not make an easy conclusion just because combination was mentioned. It's not that way, okay? Make sure that you've carefully considered all the details or information in the problem to support that this is really a combination or whether it's a permutation. Let's find out. Now, based on the description, don't care what order they are in, what does it mean? So, it implies that since you don't care about the order, you can have 2, 1, 3, you can have 3, 1, 2, or you may also have 1, 2, 3 itself, and so on and so forth. And since they are treated differently from one another, even if the subjects are the same, then that means they are counted different from one another. So that means this is a scenario wherein the order matters. And if the order matters, then we need permutation of n things taken r at a time. So the next problem is, what is our n and what is our r? So here, since we have a total of 3 options between 1, 2, and 3, so this becomes 3. And how many are we taking at a time? So we are taking everything. We are selecting 3 also at a time. So r is also 3. So what will happen is that in our formula, n factorial over n minus r factorial, we will have 3 factorial over 3 minus 3 factorial. And that is 3 factorial over 0 factorial. So what is 0 factorial? 0 factorial is simply 1. So we'll just have 3 times 2 times 1 over 1. And 3 times 2 times 1 is total of 6. So there are 6 possible combinations or outcomes that we can have in this problem. We can do listing, okay, but what's important is we know here how to apply the formula and as well as the idea of permutation. Okay, so again, the answer here is 6. Before we start answering this problem, I want you to pause this video for a while and identify whether it's a permutation or a combination problem. In this problem, we have a group of 15 people who are going to run a race. The top 10 finishers advance to the finals. Find the number of possibilities. Now again, before you jump into solving, make sure first that you clearly understand what type of problem is this. Is this a permutation or a combination? And in order for us to do that, tell whether the results order matter or does not matter. Does it matter or does not matter? So you choose between these two. And since we're just selecting the top 10, regardless of the order, just give me the 10 finishers. That's it. That's final. Then that means the order does not matter. Okay? So therefore, this is a combination problem. And if it's a combination problem, what is our N? What is our R? So here we have 15 people involved. So a total of 15, combination of 15 taken 10 at a time. So that will give us this equation. Combination of 15 taken 10 at a time with 15 factorial, n factorial over n minus r factorial. So let me put it directly here. Our n is 15. 15 minus r is 10. So get its factorial. And then 10 factorial. Now we'll have 15 factorial over 5 factorial times 10 factorial. Now to solve this kind of problem, you may expand this 15 factorial up to 10 factorial. Why? Because what will happen is that we'll have 15 times 14 times 13 times 12 times 11 times 10 factorial. And that 10 factorial will be eliminated because we have also 10 factorial in our denominator. So that's the goal. Eliminate as much as possible the biggest factorial present in the numerator and denominator. And then we can do cancellation for the rest, but let's expand first our denominator. 14, 13 times 12 times 11, then over 5 factorial is 5 times 4 times 3 times 2 times 1. And here we can do cancellation, wherein 4 times 3 is also the same as 12. 2 can be factored out from 14 and will be left with 7. And then 5 can be cancelled through 15. We'll have 3 left here. And 3 times 7 times 13 times 11 will give us our final answer, which is 3003. And this will be the total of possible outcomes if we will be taking 10 from 15. Alright, so that's it for this problem. And now it's your turn to try. Kindly answer this problem and then don't forget to put your answer in the comment section below, and we will verify your answer on our next video.